go back to the 3 sentences we had written above and try to see if it is descriptive or inferential. So just come back and look here. This says I run on an average 30 kilometers per week. I am summarizing my report that I ran for 30 kilometers per week on an average. I'm just giving you the mean. I'm just summarizing data for you. So this sentence is descriptive. It is just describing the data set for you. What is the next sentence? June to September is expected to be monsoon season. Okay. In the past, it was monsoon, but now I'm inferring, I am giving prediction that it is expected that it will be monsoon. So this is inferential. The earlier you start preparing, the more likely you clear the entrance. I am not giving any quantity. I am not going ahead and giving any number to you. I am predicting this for you. I am inferring this for you that, people who start early have higher probability. This is an inference I have from the past. This is also inferential statement. So please understand that statistics can be, it can be divided in 2 parts. One becomes your descriptive, where you're just telling some numbers through sentences. The other becomes inferential, where you infer something, you explain something. So, in the past, I see that in my class, out of 10, 8 students cleared BSc ISI. So I will infer that, my result would be 80%, that 80% people will clear the entrance exam. So inferential will infer based on past information. Descriptive will just give you the exact description that, this is 80% of the data set or 70% of the data set. Now, whenever we want to talk about descriptive or inferential statistics, something even more important pops up in stats. And this is actually sample versus population. Most important for hypothesis testing. The difference between the two. Very, very important. Let's talk about samples first. A sample is some part of the population. Population can be said to be in its entirety. It refers to everything possible, all. Like, for example, my population can be every economic honors student of the university. That's my population. I want to check how many students are satisfied with the course that is provided under, let's say, the new educational program that DU has come up with. So when I ask the sample, I will go ahead and say that out of all the economic honors students that are there in the university, pick up any 100 students and do a survey with them. So a sample is some part of the population. A population is always its entirety. Population is everything. Sample is some part of the population. Now, when I go ahead and I want to link this descriptive and inferential statistics to sample and population, this is important. See, population is never ever under my control. I cannot go ahead and deal with the entire population. It is not only difficult but impossible. Let's take an example. For example, I am talking about Abhi, we have these elections, right? Let's say I am talking about the result of the election. And before the result comes out, I want to do an exit poll. I want to understand, okay, which party is going to win, which party is going to lose. Now imagine millions of people going ahead and giving vote. I cannot ask every individual, okay, whom did you vote for, whom did you vote for? I can only go ahead and ask a sample of people that whom did you vote for and whom do you think would win? And I will bring my exit poll based on that. So once I go ahead and from this, from the entire population, I go ahead and I collect a sample of the population. My next aim would be to describe the sample. So maybe I will go ahead and describe the sample based on the averages. So I will say, okay, on an average, 49% of the people voted for party A. 37% of the people voted for party B. And remaining voted for party C. This is the result that I have got. And this I am describing based on the sample. So the sample will help you with the descriptive statistics. Once you have this in mind, you are going to go ahead and you are going to infer about the population. So you will say, okay, this sample came from a bigger population. If this is the way that sample acted, then very similar to this, my entire population will also act. So let me now generalize the results for the population and give inference about the population. This is exactly what hypothesis testing will be about. You will go ahead and you will have a population with you. Population is almost impossible to work with. Out of this population, you will pick up a sample. You will go ahead, suppose I want to make a decision whether one lot should be rejected or accepted. It's a lot of maybe the electric bulbs. So I will pick up a sample from the population for the bulbs. I will check what happened to this sample. How many were defective and how many were not defective. And suppose this sample, it clears my test. That very less were defective, 99% were not defective. Then based on this sample, I will infer about the population that the population can be accepted. So I will reject or not reject my hypothesis, which we will talk about, based on the sample by making inferences about the population. So the relation between sample and population becomes important because the population, all the things about the population will be inferred based on the sample. Now, here in sampling, we call something that is known as the paradox of sampling. Paradox of sampling says that a sample should never be misleading. It should be representative. I'll give you an example. For example, let's say that I have this population, and this population, it consisted of many kind of people. Some people who were satisfied with government policy, some people who wanted change in the government policy, some people who were fine with it, but they wanted the government to spend more expenditure on maybe some other policy. Something like this. There were different kind of people that we have. Now, while the government was doing a survey to check the happiness of the people and the satisfaction of the people, it went ahead and it went by choosing only this sample of the people who were satisfied with the government policy. So they deliberately did not choose any other kind of person. This means that the sample is misleading because it is non-representative of the entire population. This is called the paradox of sampling, and this should not take place. Whenever I choose a sample from a population, at best it should be random, and therefore we have one of the sampling techniques which is known as simple random sampling. This just says that for sample to be representative, it must choose, what do I say? It's items or objects at random from the population. Now, very similar random sampling concept with a little change, that is known as, I'll just explain this to you, stratified random sampling. This is also done randomly. But in stratified random sampling, we go ahead and we form stratas. So this stratified random sampling, the word stratified comes from strata. And strata means categories or groups. So what does this mean? So for example, let's say that we want to make sure that the voice of each person in the economy is heard. Then what we can do is we can form stratas in the economy. Like we can form these stratas based on religion, based on caste, based on gender, whatever. So based on religion, different religions can be different stratas. Based on caste, different caste can be different stratas. And now, from each strata, we will pick randomly. But in this way, we will make sure that those stratas which have lower presence also have their members in the sample. So just take an example. Suppose I just go ahead and say this is religion A, B, C, D, and E. Let's say that religion A, it had 5,000 people. B had 4,000. C had only 200. E only 50. And D had 1,000. Something like this. Now, if from the entire population, I pick up randomly, then the chances that one person from C or E will be selected will be very low. Maybe when I go ahead and make a sample from this, not even a single person from religion E got selected. But the moment I make strata random sampling or stratified random sampling, I'm saying, look, you choose randomly from E, choose choose randomly from D, from C, from B, from A, but each of the strata must be represented in the population. That is called stratified random sampling. Fine. Now, let us go ahead and let us talk about describe